afternoon from the Philippines. I would like to talk about ecosystem-based adaptation as a nature-based solution for flood protection and water provision in river basins. And I will give some experiences from projects in the Philippines and in Vietnam. Okay. The structure of forests and wetlands and the conversion to other forms of land use are major contributions to flooding in low-lying areas of river basins. And we all know this is exacerbated by the impacts of climate change. And to address this, nature-based solutions offer a cost-effective adaptation option. And in addition to that, co-benefits biodiversity conservation and human well-being. Now, if nature-based solutions focus on human adaptation, assure livelihood benefits, and are implemented as part of a climate change adaptation strategy, they are called ecosystem-based adaptation. And it's very important that they involve the participatory involvement of local people in an integrated approach, which must be part of a diverse suite of site-specific and appropriate adaptation strategies to avoid past dependencies and maladaptation. Now, let me start with looking at flood protection, specifically at flood protection along muddy coasts with mangroves. Again, the unsustainable use of natural resources and development in the coastal zone are threatening the protection function of the mangrove forests. And this results in erosion and in destruction of the mangroves, which leads to dike failure and overtopping and flooding. And as you can see here in the picture on the right, the mangroves have been destroyed here. There's major erosion going on. The dike has been protected by gabions, but it's just a matter of time when this will be destroyed and it comes to overtopping and flooding. Now, we look at the entire tidal flats and the mangrove forest as an energy conversion system, an area which converts energy from waves. And this is therefore a very effective nature-based system for coastal protection. Let me explain this further with two graphs. Here you can see a low eroded foreshore, and the waves just go across and reach the dike with very much wave energy. Whereas if you have a high foreshore covered with mangroves, most of the wave energy is already absorbed and only little energy reaches the dike. Now, in such a situation, the restoration of floodplains is a precondition for mangrove rehabilitation in such sites where erosion has already destroyed the mangroves and eroded the foreshore. And the best solution is T-shaped permeable bamboo fences placed to minimize lee erosion and stimulate sedimentation, and thereby restore the floodplains. And this creates the conditions for mangrove regeneration. As you can see here on the picture on the right, you have T-shaped bamboo fences with a gap, and outside you see the waves, and inside you see calm water. In these calm water conditions, sedimentation can happen. And it's very important that these fences are T-shaped, that they're semi-permeable, and that there is a gap, because this contributes to a better distribution of sediments in the fields, but also to better drainage and faster sedimentation. Now, overall, it's very important that the technical design and the specifications and the placement of the T-fences requires a sound understanding of coastal processes on site. It means winds, waves, currents, but also sediment transport, morphodynamics, hydrology, and coastal dynamic in historical terms as well. And I don't want to go into details because the presentation time is short, but the fact that we used T-shaped permeable bamboo fences was tested in the laboratory here in the Waveland, and then tested in the field, and this then best design options were then implemented and were effective. But what is very important is that these solutions are only feasible within a set of boundary conditions. And I have made a graph here which combines 5 boundary conditions in one: the medium grain size, the crest height above mud level as a proxy for the tidal amplitude, the gradient of steepness, and with a significant wave height and the mean wave period. And only if all 5 parameters fall within this blue area can T-fences be effectively used. Let me show this in a different way, because it's all about energy and slope. If you have a low energy coast with a low slope, then you can use T-fences. Once you get more energy or steeper slope, you need rubble mounts or even seawalls. Now, there are a lot of additional design considerations, and there's just not enough time to go into all of this. Therefore, I provide a link to a manual, which you can see here on the right, and also a link to a further description of this solution in Panorama Solutions. This presentation will be shared with you afterwards, so you have access to this additional information. What is very important is that it is not enough to put a solution into place. What is also important is to make the solution sustainable. And in the case of mangroves, this can be best achieved through shared governance. Because what is the root cause? It's unsustainable use of natural resources, and development in the coastal zone and also in the catchment area, upstream dams and so on, is causing the erosion. And so we need to address the root cause in order to provide a sustainable solution. And this can be done through the involvement of local communities, through shared governance or co-management. Again, this is a very complex topic, so here is a link to a detailed description of one example of solution in terms of co-management, but also the graphic here shows you very clearly, once you have erosion and you address it through restoring the floodplain and then get natural regeneration of mangroves, if you don't stop this cycle, it will start again from the beginning, and this needs to be avoided. A common question which is always asked, what are the costs? What are the benefits? Is it really cost effective? I would like to give you an example from Vietnam, from the Mekong Delta. Here's a study with the appropriate link. And this study in the Mekong Delta compared the values of mangrove planting or rehabilitation with dike upgrade based on saved wealth and saved health. Now, what does it mean? I don't want to go into details what saved wealth and saved health means, but it's very clear that saved wealth index per US dollar invested for mangroves is about 19 times higher than that for dike upgrade. It means it's just much better in terms of benefits and cost effectiveness. And in addition, mangroves provide health benefits of 243 disability adjusted life years over a period of 20 years, while the dike upgrade does not deliver any positive health impacts. And this can be shown in so many other examples. Let me just give you one short example from Fiji, where the benefit to cost ratio for ecosystem-based solutions is much higher than the benefit to cost ratio for engineering solutions. Now, I've been looking at flooding from the seaside. Let's look now at actually flooding and water issues from the other side. And it's about EBA measures for flood protection and water provision in addition to flood protection. EBA measures can enhance water availability, improve water quality, and reduce water-related risks. In addition, they generate livelihood, economic, and environmental co-benefits. But it's very important that we need to look at the effectiveness of such measures. And conservation of existing catchment forests, existing mangrove forests, and existing wetlands are effective EBA measures, and they can be complemented, but not supplemented by appropriate wetland and forest rehabilitation using native species. And I on purpose use the term rehabilitation instead of restoration because there's a slight difference in meaning. Now, it's also very important that the overemphasis on tree planting, which is often done for carbon gains under the umbrella of climate change mitigation, this may actually lead to adverse impacts on local communities and on biodiversity. But we don't want any biodiversity trade-offs. And also distracts from the need to protect intact ecosystems. So, for example, conversion of peatlands for tree plantations is not a good thing to do. Let me give you one example which works and is really good thing to do, and these are locally established protected areas, because they can further contribute to forest and wetland protection. For details, I would like to refer you to HE Target 11, other effective conservation measures. Now, as I already said, protect and manage is more effective than rehabilitate and restore. This slide shows you an example of that. The potential for cost-effective climate mitigation from nature-based solutions on land, if you look at the entire potential as 100%, 80% of it, the vast majority, is actually due to protection of intact lands and to the management of working lands. And only 10% of the entire potential comes from the restoration of forests. Therefore, it's much more effective to protect and manage than to restore. It's an option, of course, but if you have limited funds, if you have limited possibilities, that's where you should go for. An appropriate link to the source is also given here on the slide. Now, when we talk about water management, we often talk about integrated water resource management, and I want to look at integrated water resource management in the context of EBA very briefly. Water availability in adequate quality is highly dependent on healthy ecosystems and their provisioning functions and services. And healthy ecosystems also reduce water-related risks. Now, integrated water risk management has its own rule, but it would be good if more emphasis could be put on promoting the ability and strengths of healthy ecosystems to reduce vulnerabilities to climate change in watersheds or river basins. And therefore, integrating the concepts and approaches of EBA and integrated water resource management could support the mainstreaming of climate change adaptation and risk management into integrated water resources management. And if this is done, then EBA measures should be part of land use planning and integrated into river basin-wide plans as participatory approaches to conservation and development. Now, I would like to conclude by summarizing the main points of this rather broad presentation with a lot of complex issues, particularly engineering aspect of rehabilitation of eroded foreshores. The use of area, which means tidal flats and mangroves, as a nature-based coastal protection system is very effective and provides co-benefits. It can also be called area coastal protection. Engineering is required in erosion sites and needs sound understanding of dynamic coastal processes, and it includes historic processes as well. Now, EBA solutions such as the T-shaped permeable bamboo fences only work within a specific set of boundary conditions, and they must be site-specific and appropriate. There is no one solution fits all, and there is no simple way of taking one solution and transfer it to somewhere else unless you understand the site conditions and select the appropriate solution. In addition, there is a risk of pitfalls, and it's very important not to use nature-based solution as a blanket argument for putting in place solutions. We have to really make sure that we avoid pitfalls such as greenwashing or overemphasis on tree planting. Therefore, global standards for NBS have been developed, and they should always be followed when designing an NBS project. Different solutions and their costing should be part of an integrated river basin master plan, which integrates EBA and integrated water resources management. And such an integrated plan should include mangrove forest and wetland protection and sustainable use management, or in other words, conservation, and involve local communities in the conservation and development approach. And if this is done, then we can achieve effective water provision and flood protection, as well as co-benefits. Thank you very much for your attention.